Hello students, in this video we'll see examples of how to compute the inverse Laplace transform using the series method. So we'll consider two examples. Let's find a function whose Laplace transform is 1 over s minus 3. This is a relatively simple example. We know from experience that the answer will be e to the 3t. Let's verify this using series. We can factor out an s. 1 over s minus 3 is 1 over s, 1 over 1 minus 3 over s. Now this term in brackets is a geometric series, so I can write this as 1 over s, the sum, and goes from 0 to infinity, 3 over s to the power n. Now I will simplify this to be the sum, and goes from 0 to infinity, of 3 to the n over s to the n plus 1. And what we will do is we will add in to this problem an n factorial on the top, and we will divide by n factorial on the bottom. Doing so, we now can focus in on this term over here, which is easy to inverse Laplace transform. That will inverse Laplace transform to t to the power n. So when we inverse Laplace transform this, we will have the sum, n goes from 0 to infinity, of 3 to the n, t to the n over n factorial, which we write as the sum, n goes from 0 to infinity, of 3t to the n over n factorial. And this is the Taylor expansion for e to the 3t, e to the 3t, and we have verified what we knew. Now let's consider the second example, slightly more complex. Let's find the inverse Laplace transform of 1 over s squared minus 9. We'll do the same procedure. 1 over s squared minus 9 can be written as 1 over s squared times 1 over 1 minus 9 over s squared, which is a geometric progression. This is 1 over s squared, the sum, n goes from 0 to infinity, of 9 over s squared to the power n. So what we will do is we will write this as 1 over s squared, the sum, n goes from 0 to infinity, of 9 to the n over s to the 2n. And we will change this to the sum, n goes from 0 to infinity, 9 to the n over s to the 2n plus 2. And we'll introduce our factorials. So I will introduce a factorial of 2n plus 1 factorial on top, and 2n plus 1 factorial in the denominator. And these terms are easy to inverse Laplace transform. These will inverse Laplace transform. The sum, n goes from 0 to infinity, 9 to the n over 2n plus 1 factorial. And then I will have a t to the power 2n plus 1, which can be written, I can write this as 3 to the 2n. So I can write this as 1/3 the sum, n goes from 0 to infinity, of 3t to the 2n plus 1 over 2n plus 1 factorial. And this is the Taylor expansion for sinh. So this will be equal to 1/3, and then we will have a sinh of 3t. And we can verify this formula is correct by applying the ordinary partial fraction result. Thank you very much.